My name is David, and this is the determinant of a matrix exercise for CST-215. For this exercise, we were asked to write a program that when given the size of the matrix, n, and its values as inputs, the program were to compute the determinant of the matrix, and all of this was to be done using a recursive algorithm. Before walking you through the code, let me run the program. As we run the program, we are asked the size of the matrix. By entering 3, we are creating a 3x3 matrix. It proceeds by asking us to fill in all the values in our 3x3 matrix. We begin by entering a value for the matrix at position 0, 0, 0, 1, 0, 2, and then asks for the value at position 1, 0, and so on. The program then outputs the resulting matrix and proceeds to calculate its determinant. The program goes through the series of calculations, which will be explained later in the video, to finally calculate the overall determinant of the matrix. Now let me run you through the code. The code begins by receiving the size of the matrix from the user and assigning the value to n, and filling in the entire matrix through a nested for loop by receiving every entry from the user as well. The program continues by calculating the determinant of the matrix by calling the determinant of matrix function. Inside of the function, two parameters, the matrix and its size, are received, and a variable representing the value of the determinant of the matrix, d, is initialized to 0. Given that this is a recursive function, our exit condition is when the matrix size is a 2x2. The determinant of a 2x2 matrix is the subtraction between the entry at position 0, 0 multiplied with the entry at position 1, 1, and entry at position 0, 1 multiplied with entry at position 1, 0. Thus, if the size of the matrix is 2x2, the program simply calculates and returns the determinant using the above equation. To calculate the determinant of a matrix n by n, where n is greater than 2, the entry at position 0i, where I begins in 0, is treated as a coefficient that multiplies the determinant of the corresponding reduced matrix. Thus, for every element in the first row, this corresponding reduced matrix consists of the values of the original matrix not in the row or column of the coefficient. This entire process is repeated for every coefficient of the first row of the matrix. Thus, if A, B, and C, and so on, are the coefficients of the first row of the matrix, the entire equation is in the form of A times determinant of the reduced matrix minus B times the determinant of the reduced matrix plus C times the determinant of the reduced matrix, and so on until the rest of the coefficients multiplied with the determinant of the corresponding matrix are added and subtracted accordingly. This process of finding a reduced matrix is done until the final reduced matrix is a 2x2 by recursively calling the determinant of matrix function with the reduced matrix. After every coefficient multiplied with the determinant of the matrix are added and returned for every recursive call, the determinant value is returned and outputted. Thank you for watching.